Do you hear me? All right. So next week, you will solve example like this. Today I got the help how to create an online Moodle test. So oh wait, yes. So it's computer science engineers seminar. Yes, second test is next week. The YouTube channel, if you haven't got, and the Dropbox link you can see in the YouTube right now. All right, let's see the questions. So second text is next week, but wait, the test will be during the seminar. So, I mean, by default, if you have a seminar, you have time. Are you computer science engineer? But how can that be? I mean, usually if you have seminar in, let's say in this time, you can't have any other lecture. No need. Chemical engineers will come from 2 o'clock. So I don't want to be rude, but technically this is not my problem. So since we have seminar, we should write on the seminar. If you have any other lectures, you should solve at that lecture, because for the others, this seminar is okay. How many of you have any? How many of you have parallel lecture seminar? I see. So you are not the first year student. That can cause, of course, problem. And how did you write the first test? If it's only 30 minutes, no need to worry. the test will be, let's say, only 1 hour. The time, I mean, I can set up, for example, you can write the test at any time between 12 and 14, and the length of the test is 1 hour. So if you start half an hour later, you will finish half an hour later, but it will work. So it's if it's really 30 minutes and not for the whole 2 hours, no need to worry about it. Are you all registered to the Moodle? Let me show you what I mean. Just a minute, I'm just checking the Moodle class. One, two, three, four, five, six, 7, 8, 9, 10, 11. Yes, it will be only 2 questions. So, if you don't see your name in this list, you are not in the Moodle. That means you won't be able to write the test because this will be in the Moodle. Are you registered for this Thursday seminar? Because there is also technically, what's your name? I think it's not Madraxi, your name. So can you add your name or perhaps your Neptune code also? Wait a bit, I try to add you. No, you are there. Madrexy. And sorry, I can't pronounce your name. Do you see yourself? All right. All right, I have to remind the others to add them to the seminar. All right. That's something we can do. Give me 5 seconds because I have to send a mail to another group because you are about 16, but the seminar one, I can see only them. So they should be here. I don't understand. If the email said you are in a seminar, no, you are not. Let's just check it. All right. I think you are ready with that one. Solve some example. The first one is very easy. I think we solved it last time also. The seesaw example. Oops. This is a massless seesaw. The axis of the rotation in the structural point of the seesaw. If you put M1 here and M2 here, wait, sorry, with mouse it's hard to draw parallel lines. G1, G2, the level arm of this force is R1, the level arm of this force is R2. If M1 is 2 kilogram, M2 is 3 kilogram. If R1 is 1.5 meter, so this is 1. What is R2? and tell me what is the torque 1 and torque 2. Torque is a vector. It would be nice to say what is the direction of torque 1 and what is the direction of torque 2. These are a balanced seesaw. Try to solve it. Yes, that's true. So what is the condition for equilibrium? The tau 1 has to be equal to tau 2. And what is tau 1? If you look at like a vector, this is R1 cross G. And do you know what is the direction of the torque? Of the torque 1? If you place your phone or screen on the table, is it upwards or downwards? This drawing can help you. up, yes. So if I draw with a different color, so this is the tau 1, it goes upwards if you place this screen on the table, and this will be downwards. And the equilibrium says if you sum all the torque, equilibrium means angular acceleration is 0, and the net torque equal moment of inertia times alpha is the condition for balance, this one. I think that will be easy. See, so let's continue with a bit more complex. The pure rolling. Here we have a flat surface, and we try to rotate a cylinder with the force that goes through the axis of the rotation. This cylinder has a mass, a radius. The mu between cylinder and surface is non-zero, therefore there must be a friction. This is an observation. If you rotate something with a force, it should move somehow. The question is whether it's a pure rolling or non-pure rolling. The pure rolling equal to the fact that the friction between cylinder and the surface is static. When can we say that this is a static friction? When the force, the static friction force, which is an unknown here, is smaller or equal than the mu times perpendicular force, as this, and this perpendicular force right now is the weight. Alright, so this is, if this is pure rotation, we know the acceleration and the acceleration can be different, can be independent. These are connected by the radius. So the acceleration and the angular acceleration is connected. This is this small story about what pure rolling means. Yes, I think this is the one slide I tried to explain. Alright, so this is the equation 1. The other equation is technically the Newton's second law, which said the net force is equal m times a. What is the net force here? Let's choose the positive direction to your right. The net force is the force I pull this cylinder minus the unknown static friction equal m times a. This is the second one. The third one is the rotational form of Newton's second law, which says the net of the torque will be equal to moment of inertia times angular acceleration. So the net torque equal moments of inertia times angular acceleration. What is the net torque? What is the torque caused by this force? The torque is force times level arm. Level arm is the distance between the vector and the origin axis of the rotation. If a torque goes through the axis of the rotation, the level arm will be zero. So the torque from this force is zero. Therefore, the net torque is the force, the static friction, times level arm, and the level arm, since the distance between this force and the center of rotation is r, it's d times r. And we know that this is a cylinder. We know the cylinder has the moment of inertia 1 over 2 mr square. So this is the I, capital I, times alpha. So technically, this is the equation number 3. So, one equation, two equation, three equation, one unknown, and the third unknown. Three equation, three unknown. I will give you 10 minutes. Try to solve it with the parameter F equal 100 Newton, M equal 20 kilogram, mu equal 0.8, and R equal 0.5 meter. Equations, parameter, try to solve it. I wait 10 minutes maximum, but if you are ready with that, we can continue earlier. Let's solve it. 3 unknown, 3 equation. Not easy, but not that hard. So let's start with the number 3. Instead of r square, we should write simple r times r. This is r square. And if the assumption is true that it's a pure rotation, r times alpha, which is here, will be equal to a. We have r on the both sides. Therefore, combining these two, we know that t equal 1 over 2 ma. Don't forget, this is true only for cylinder when it's 1 over 2 mr square. If it's a ball, 2 over 5 or 2 over 3 mr square, that will be a different number. And let's put this number, or let's put this, no, not this color, result here. I've started. Do you see the YouTube? Do you see the YouTube? All right. F minus t, but instead of t, let's write 1 over 2 ma equal ma. F equal 3 over 2 ma. And this is the equation we are looking for, since f equal 100. 3 over 2 times 20 times a. Finally, this is one equation, one unknown. It's 210. Yes, a will be 3.3. So, in the test, you will write decimals. So don't forget, no 1 over 2 or 10 over 3 or 100 over 3 is allowed. But we are talking about the same thing. If we know the a, based on this one, we know the alpha equal a over r. A over r is half, so alpha will be 6.6. And this is meter per square. Yeah, thanks. This is 1 over s square. And let's use this one for calculating the t. 1 over 2, 20. Yes, you're right, that's technically 10 over 3. So 10. Oops. 100 over 3. This is the 33.3 Newton. Still, we are before the big question whether it is true. So let's use a different color. So the final check, orange. Is it true? Is it true that 33.3 Newton smaller equal than mu is 0.8. The weight of the body is 200, which is 160. Is it true that the 33.3 is smaller than 160? Yes. In this case, we can accept this result, and that's the final result. Don't forget to check the condition for pure rolling. Is it clear to everybody how to solve this example? Alright. 3 unknown, 3 equations, checking the condition for pure rolling. I do not worry about you. Alright. What if I ask if the initial speed was 0 and the initial position was also 0? Where is the body in 10 seconds? How can you solve it? So if the x coordinate is this one, and this is the origin of the x, where is the body at 10 seconds? So you remember, if x null is 0, v null is 0, the formula is simple: xt equal a over 2 t square. A over 2 is about 1.66. T square is 100, so it's about 166 meter. All right. The A acceleration by 3.3 meter per s square. Let's say the initial position of the cylinder was 0. The initial speed is 0. Do you remember integrate boundary conditions? So the delta v t is nothing else, just the integral of acceleration, this 3.3 from 0 to t. This is 3.3 times t. The vt, which is the v0 plus delta vt, is therefore 3.3 times t. So the body with this acceleration will have the velocity like 3.3 times t. What is the delta xt? The delta xt is the integral from 0 to t, the 3.3 times t, which is 3.3 divided by 2 t square. The full form of xt is the x null, which is 0, plus delta xt is this 0.66 t square. At t equal 10, this is 1.66 times 100, which is 166 meter. Yes, Ethan, I think you're right, except it's not 33.3, but it's 3.3. Yes, so it depends how long you want to write. So A is 3.3333. If I write 6 here, means I use the second one. If I use 165, you use only the first digit. But do not worry, there will be an interval we can accept. And I will try out nice numbers, not this unlimited. Alright, so the chemistry students are waiting for me. Any other question? Then thanks. See you next week and we will finish it soon, this seminar. Bye.